In this video, I will talk about Bayes theorem. Bayes theorem, it's a conditional probability, as you might all be aware of. You would have seen and read in class 12th textbook also. But I will cover some important things about Bayes theorem. That the question generally contains a phrase "found to be." Wherever the "found to be" is there, you should understand it as a problem of a Bayes theorem. I have just tried to explain with a simplicity once again. If there are n number of non-empty sets, I have given it through a Venn diagram also, and which constitute the complete sample space, that is E1 union E2 union En. If there are n such sets and they make a complete sample space, and there is an event A, I have made it here with the blue line. This is your event A, which is interacting with each of the events. So in each of the events, A is occurring. Then the probability of occurrence in a particular event, provided that A has occurred, is given by this probability, which is P probability of EI multiplied probability of A oblique EI divided by summation of J from 1 to n P of E J into P of E oblique EJ. So you may find it little bit, uh, mm, uh, little bit in the sense that you may not understand it directly, but once I will explain it through an example, it will become easier for you. So I will cover the first example here, which is a question in the CBSE also. A bag contains 4 red and 4 black balls, and another bag contains 2 red and 6 black balls. So one of the two bags is selected at random, and a ball is drawn from the bag which is found to be red. So I have used there, the phrase has been used, found to be red. Find the probability that the ball is drawn from the first bag. Here I have made it so since there are two bags, they are divided into two partitions, E1 and E2. So these are the two bags, and E1 union E2 is S. So the green circle which I have drawn is an event A, which is nothing but red balls. So bag 1 contains 4 red balls. So I have put a number 4 inside and 4 number outside, which is the black ball. E2 contains 2 red balls and 6 black balls. Okay. So E1 intersection A means in bag 1 there are 4 red balls, and in bag 2 there are 2 red balls. So this is E1 intersection A. So it is very simple from the Venn diagram, which appears to be little difficult when we try to see the formula. Okay. So once you understand this, you will understand the formula also. Now probability of occurrence of A means occurrence of red ball from the bag 1 is given by P of E1 intersection A divided by P of En. I have given a separate video on conditional probability. You may refer to that. So this is the formula being used. Now probability of taking a ball from the bag 1 is 8 by 16 because there are 8 balls. So 1 by 16, 8 by 16, which is 1 by 2. Probability of getting a ball from bag 2 is also 8 by 16, which is 1 by 2 because 8 balls are there in that. P of E1 intersection A, you already know there are 4 such balls which are in bag, which are red and in bag 1. So 4 divided by 16 is 1 by 4. P of E2 intersection A is 2 by 16, which is 1 by 8. So I can find out the probability of getting a red ball from bag 1 is nothing but P E1 intersection A divided by P of E1. So 1 by 4 divided by 1 by 2, which is 1 by 4 into 2. So 1 by 2 is the probability. Similarly, probability of getting a red ball from the second bag is nothing but P of E2 intersection A. I have separately calculated all the probabilities with the ease of the Venn diagram so that you understand it easily. So it is 1 by 8 divided by 1 by 2, 1 by 4. Now probability of getting a red ball. So it can come either from the bag 1 or from the bag 2, and both are disjoint. They are mutually exclusive. That's why the probabilities are added. So the same is being used here in the Bayes theorem formula also. Here all the probabilities gets added. So this is the formula that comes into picture, because it is written they are non-empty sets and they are disjoint. They are pairwise disjoint. So since the sets are disjoint, so they are mutually exclusive, and in the mutually exclusive events, the probabilities gets added. So here also I am adding the probabilities because it is from the either from bag 1 or either from bag 2. So if I get it from bag 1, I am using the formula of the conditional probability, probability of A oblique even into probability of even, probability of A oblique E2 means same formula. This formula I have used, and then this gives the same denominator which I have written in the formula. So 1 by 2 into 1 by 2, all the probabilities I have already calculated. Probability of getting a red ball from the bag 1 is 1 by 2, and the probability of selecting the bag itself is 1 by 2. Similarly, the probability of getting a red ball from the second bag is 1 by 4, and probability of selecting the bag itself is 1 by 2. So all the probabilities are calculated. So this gives 3 by 8 is the probability when solving this. This is the probability of getting it 3 by 8. 3 by 8 is the probability of getting a red ball. Now probability of getting, I have separately written probability of getting it from bag 1, probability of getting it from bag 2. Now probability of getting a red ball is now 3 by 8. So now ball is found to be red. This is found to be red. What is the probability of getting it from bag 1? So we already know that we have received the red ball. What is the probability that it has come from bag 1? So it's a conditional probability. So again using the formula of conditional probability, which is nothing but the Bayes theorem, because PA is nothing but summation is used. PA in the PA this summation is being used. So 1 by 2 into 1 by 2 divided by 3 by 8. So this gives 2 by 3. So this is how you can understand the Bayes theorem. This Bayes theorem with a very simple example, I have tried to explain it to you. Now there is another way, because it's a conditional probability. I have written in my first statement, it's a conditional probability. A ball is found to be red. What is the probability that it has come from bag A, bag 1? So you can see the formula question itself. Found to be red because there are 4 red and 2 red. So total there are 6 red balls. If out of 6 red balls, if the red ball has to come from bag 1, then the probability will become 4 by 6. So which has come from the, this has come from the Bayes theorem. However, you can directly do number of red balls are 6 and number of red balls in bag 1 are 4. So the red balls from bag 1 is total favorable events divided by total events. So this way the answer has come directly. The answer has come directly. So Bayes theorem, you can see we have solved it from the Bayes theorem. However, if you see the question, you can directly solve it without applying the Bayes theorem with the favorable events divided by total events. I'll cover another question. A garment showroom has 500 shirts of brand 1, 100 shirts of brand 2 and 1000 shirts of brand 2 and 2000 shirts of brand 3. There are 10%, 20% and 10% black shirts in the brand 1, 2 and 3 respectively. A shirt is selected and found to be black. If and it's found to be black, what is the probability that is selected from brand 2? So direct answer is I can immediately find out how many black shirts are there. So it is 500 because there are 10% shirts. So 500 into 0.1. So 1000 shirts are in brand 2. So 1000 into 20%, zero point 0.2 and 2000 into 0.1. So this will give the total number of black shirts, out of which I am asking what is the probability of getting it selected from brand 2. If I select it from brand 2, so it will become 200 divided by 450 because there are 200 black shirts in brand 2. So the favorable outcomes are 200, total is 450. So we get 4 by 9. However, by using Bayes theorem, I get total number of shirts 3500, which we know. So the probability of getting a shirt in brand 1 is 1 by 7, in brand 2 is 2 by 7 and in brand 3 is 4 by 7. Now probability of getting a black shirt, again, because probability is 0.1 of getting it from brand 1, and zero point 0.2 is from brand 2, and zero point 0.4 is again from brand 3. And they are selecting probability, and the selection and of getting a shirt in different brands is 1 by 7, 2 by 7 and 4 by 7. So the same summation formula which is used in the Bayes theorem is applied, and we have calculated, because they are all mutually, either of them will be happening. Either it will be selected from brand 1 or from brand 2 or from brand 3. So either, wherever either or is used, the mutually exclusive events happen, and we add the probability. So the probability of getting a black shirt is 9 by 70. Okay. So if it is to be come from brand 2, then again conditional probability formula is being used. So 2 by 10 into 2 by 7 divided by 9 by 70, which I have already calculated. So I get here as 4 by 9. You can see here this answer we have directly got. So I have explained it with the help of the Bayes theorem and with the help of the formula. So this way you can get the answer in less than 30 seconds, which may be very useful in the competitive exams if this kind of questions comes in JEE Mains. So you can directly calculate and write the answer. I will come to another example which is given in the class 12 CBSE book. An insurance company insured 2000 scooter drivers, 4000 car drivers and 6000 car drivers and truck drivers. 6000 they are truck drivers. A probability of accidents are 0.01, zero 0.03 and 0.015 respectively. One of the insured person meets an accident. What is the probability that he is a scooter driver? So I have just calculated how many drivers who can favorable. There are 2000 into 0.01. These many drivers who can meet an accident, because this is the probability, out of divided by the total number of drivers who can meet an accident. So 2000 into 0.01. So this becomes favorable cases, this becomes total cases. So I 20 divided by 20 plus 120 plus 900, so 20 divided by 1040, I'll get 1 by 52. So students, you can also try this, like I have used the Bayes theorem and solve the question. You can apply the Bayes theorem here also and solve the question, and you will get the same answer, which you can check in your books also. So Bayes theorem, hope you would have understood how to solve the questions quickly with the Bayes theorem and what is the basic fundamental in Bayes theorem. So I have covered very interestingly in one of my videos which is available in my app, and if you have to clearly understand every and each and everything of the probability, then you must refer to that course. Thank you.